All right, problem number 8. We have a rectangular pen is built one side against the barn. If 400 meters of fencing are used for the other 3 sides, what are the dimensions of the area that maximize the area of the pen? So we have a picture, but that's not what we're looking at in part A. We got 2 parts. So what we're being told is we have some barn. Okay, that's one side. We're going to build fence. So we're going to call this X, this side Y, and this side X. And what we know is we have 400 feet of fencing. So we know that 2X plus Y equals 400. And we want the area. Okay, maximum area. Area is equal to X times Y. So we want to maximize the area. So we got to come up with these two. This would be our constraint, and this would be our objective function. We're going to solve this one for Y. So this function, another version of it, I just subtract 2x, so we'll get Y equals 2x plus 400. We're going to solve or plug that in to the area function. So we're trying to solve for area. X times the Y, which is going to be equal to 2x plus 400. And then we'll distribute 2x squared plus 400x. We'll find the derivative because we want to find the maximum. So a prime would be equal to 4x plus 400 using the power rule. Set this equal to 0. And then we will, I'm sorry, I made a sign error again. I'm looking at this. So whenever I move the 2x over, this should be a negative 2x. This should be negative, negative. So it should be a negative, negative. Okay. Subtract 400. Divide by negative 4. I'm kind of looking at head mentally. I can see it's going to work or not when I get to the end. So this will be a positive 100 equals x. So we're saying that x equals 100. We will plug that in to our original constraint. So this is 2 times 100 plus y equals 400. And that will give me 200 plus y equals 400. Subtract 400 and we get y equals 200. So we get the x equals 100. Each x 100, 100 plus 200 is 400. So in part A, the dimensions to maximize the area, the sides perpendicular to the barn, the 2 sides should be 100 meters. And then the side along this parallel, which I called Y, should be 200. All right, so now we have part B. Part B says a rancher wants to make 4 identical and adjacent rectangular pens, each with an area of 100 meters. What are the dimensions of the pen that minimize the amount of fence that must be used? So this time we're trying to minimize the fencing so that we get 4 sections that equal 100. Okay, so with that image, so we're going to use fencing 1, 2, 3, 4, 5. This time we have 5 sections. And then we have We can just say, I guess we need to say y. 1, 2, 3, 4, because we need x times y to be equal to 100. All right, so part B, we know that x times y equals 100, and we are trying to figure out the perimeter that minimize. We're trying to figure out the 5x plus 4y. So that we use the smallest amount of fencing possible. All right, so what we'll need to do is, again, solve for x or y. So let's just solve for y. Y would be equal to 100 divided by x. We will plug that in for y. So we'll have p equals 5x plus 4 times 100 divided by x, which will be 400 over x. To get rid of the fraction, I would want to, I guess I don't know if I'll multiply through by x. I'll just get a common denominator here. Give me 5x squared over x, multiplying top and bottom by x, plus 400 x, nope, 400 over x, just multiply by the 4. And so this will give me 5x squared plus 400 divided by x. That's equal to p. So now we're going to find the derivative, p prime. We will have to do quotient rule, low d high, high d low. So it'll be x. Derivative of the top, 2 times 5 is 10x. Derivative of 400 is 0. So low d high minus the top. Low d high minus high, top d low. Derivative of x is times 1. All over low squared. And we're going to set this equal to 0. So I'm running out of room on this page. I'm going to have to flip to another page to set this equal to 0 and solve for x. So I'm going to rewrite our derivative. P prime is equal to x times 10x minus 5x squared plus 400, all divided by x squared. All right, so setting this equal to 0 and simplifying, this will give me 10x squared. Distribute the negative, minus 5x squared minus 400 all over x squared. 10 minus 5 will give us 5x squared minus 400 all over x squared, still equal to 0. So now we can multiply by the x squared, and that will give me 0 equals 5x squared minus 400. Add 400 to this side. 400 equals 5x squared. Divide by 5. Oh, I'm sorry. Didn't realize that was all the way off the page. Divide by 5. 400, that'd be 80. Equals x squared. And then we'll take the square root of both sides. So we get plus or minus square root of 80. Since we're dealing with measurements, we would assume that we cannot use a negative. So we're saying that x equals the square root of 80. And therefore, if we go back to our area function, 100 equals x times y, where x is square root of 80. square root of 80 times y, and divide by square root of 80, so y equals 100 over the square root of 80. Now this is unsimplified. We can probably break this down. We can say 10 times 8, and then 2 and 5, 2 and 4, pair of 2's, another pair of 2's. So that's a 4 we can bring out, leaving a square root of 5. So we have 100 over 4 square roots of 5, divide by 4. And we get 25 over the square root of 5, which rationalize the denominator, and that will give us multiplying square root of 5 on top and bottom. 25 square roots of 5 over 5. And you can reduce, divide by 5, so we get 5 square roots of 5 for the y value. Alright, so to minimize each of the sides perpendicular to the born, which are the x, should be square root of 80. Square root of 80 can reduce to 4 square roots of 5. And then the y simplifies to be 5 square roots of 5. I'd say it's good.